And then for now we are going to do practice problems, for vertical circular motion, and we also call it a linear circular motion. Let's read the statement. The statement says that a 0.6 kilogram ball is swaying in a vertical circle, key point, vertical circle, ne? Of radius of 1.2 meters at the bottom. It moves, ne? They say at the bottom it moves with a speed of 6 meters per second. The question says calculate the centripetal force. Understand, for you to calculate the centripetal force, you must be able to draw your free body diagram, and everything you draw what's happening, ne? You don't just do things without drawing. Let's draw the diagram. This is the diagram. And then they are telling us a 0.6 vertical circle, ball swing on a vertical circle, and they told us is swinging at the bottom here, ne? And this is our centripetal force. And then they say the radius is the radius is 1.2 meters. Understand? And they told you the mass of the object is the mass of the object is 0.6 kilogram. Understand? And they tell us the velocity is moving that direction. The velocity is 6 meters per second. They say calculate the centripetal force at the bottom as it moves at that angle, ne? We know as long as that thing is moving, it is it has a tension force, ne? So let's draw a free body diagram first. This is our free body diagram. This is our tension, and that's our that's our FG. We know you cannot just conclude a centripetal force equals to mv squared divided by the radius. Understand? That's the formula to calculate you can conclude, ne? You know the formula to calculate the centripetal force, ne? You know the centripetal force is equals to that. So you are going to say A centripetal force equals to mv squared divided by divided by the radius, ne? What is the mass of the object? They gave us the mass is 0.6 kilogram. The velocity they say is is 6 squared divided the radius is 1.2. Let me fetch my calculator. And then when you hit your calculator here, you are going to press you are going to say 0.6 kilogram multiplied by 6 squared divided by 1.2. Then your answer is is 18 newtons. Understand? So you are done with you are done with question letter A. Let's do B. At B they say calculate the tension in the string at the bottom. They want at the bottom, not at the top. So this is the free body diagram where at the bottom. It's the free body diagram where at the bottom, ne? Note that the free body diagram here and here are not the same, even the tension, ne? So I told you that F net equals to equals to centripetal force. Understand? F net, I told you choose the force that is going to the origin of the circle to be positive. At this point, the force that is going to the origin at the bottom is is the tension force. It's going to the origin. You choose it to be to be positive, meaning we're going to have something like we're going to have tension minus gravitational force equals to centripetal force equals to mv squared divided by the radius. Yeah, they want the tension. We know the tension equals to mv squared divided by the radius plus mg. Understand? You can substitute your value of the centripetal force. Remember, you calculated it here, or you can just substitute the values, ne? You'll get the same thing. You got the answer there as you got the answer as 18, ne? Plus you substitute your mass there. Your mass is 0.6, then your gravity is 9.8. Then you press your calculator. You are going to say 18 plus 0.6 multiplied by 9.8, which your answer will get. Your answer as as 23.88 newtons. Remember, force is measured in newtons. Then let's check letter C. Letter C, they're saying calculate the weight of the ball. You know that weight equals to what? Equals to mass times gravity. Understand? What is the mass of the object? The mass of the object is 0.6 kilogram. The gravitational force is 9.8. Then you press your calculator. Say 0.6 multiplied by 9.8. You get your answer as what? As 5.88 newtons. Weight is a force. It's measured in what? In newtons. Then another question, letter D says time to complete a full revolution. Revolution is the same as what? Is the same as what? Cycles. Ne? Revolution is the same as cycles. Ne? They're saying calculate the what? The time to complete one full cycle. Remember, key point here is what? The key point here is what? Is one full cycle. One what? One cycle or one revolution. Understand? That's the key cycle. Ne? I told you the formula to calculate what? The cycle. You know the period equals to what? Equals to time divided by what? By number of cycle. Or and another formula is the frequency equals to what? Equals to number of cycles divided by the time. Understand? So they say calculate the time to complete one full revolution. Understand? How to calculate the time? You don't have the what? You don't have the period. Understand? But then you know the formula. We have that formula to calculate velocity. You remember that formula? Let's say letter D. You remember that formula says what? Velocity equals to 2 pi r divided by the what? Divided by the period. Ne? We're looking for the period. We don't have time. We have only number of cycles. Understand? Meaning you are going to use this formula. Understand? So this formula, you have your velocity there. Your velocity is what? Your velocity is 6 meters per second. Your velocity is what? Is 6 meters per second. Let's put t subject of the formula. We have velocity multiplied by t equals to 2 pi r. Understand? Therefore, our period is what? Is period equals to what? Equals to 2 pi r divided by velocity. What is 2 pi r? Our radius is what? Our radius, we got it as what? As 1.2 meters. We have 1.2 meters divided by the velocity, which is 6. Therefore, you press your calculator to get your what? To get your period. You're going to say 2 multiplied by pi multiplied by 1.2 divided by 6. Therefore, your period is what? Is 2 over 5 pi. Then you press SD. You get what? You get your answer as what? 1.25 what? Seconds. Remember, this is period. Is time is measured in seconds. They want what? The time to complete how many cycles? 1 cycle. Ne? Number of cycles is what? Is 1. One what? 1 revolution. Revolution the same as cycles. Understand? So we know the period equals to what? Equals to time divided by number of cycle. Our period is how much? Is 1.25. Is 1.25. They want the time. Number of cycles is how many? Is 1. Meaning our period, our time is going to be 1.25 seconds. This is your final answer. Now let's go to the following question. The following question is question number 2. They say what? They says a 0.5 kilogram stone is tied to a string. A string is a tension. Understand? A span in a vertical circle. Key word, vertical circle. It means we are talking about which something that is what? That is acting vertical, is circulating vertical. Understand? They say the radius is what? The radius is 1.5 meters at the top, which means when they say at the top, they are talking about here. Understand? At the top, key point. At the top, its speed is what? Is 4 meters per second. Let's assume it's going that direction. Understand? It means its speed is what? Its speed is what? Is 4 meters per second. Understand? And then they gave us its radius. From here to here, we have a tension. Ne? Remember, it's being held by a what? By a tension. And that tension has a length of what? A vertical, a string is spanned in a vertical circle of a radius of what? 1.5 meters. Understand? Remember the SI unit meters, it means they are talking about the length. In newtons, they will be talking about a force. Ne? Then the question says find the centripetal force. Ne? You know always all the time centripetal force equals to what? Let's say letter A equals to mass v squared divided by radius, or what? Or equals to mass times what? Centripetal acceleration. And you know that centripetal acceleration equals to v squared divided by radius. Don't just cram this formula. Understand? You must know, or this thing comes from here. They want the centripetal force. You substitute your mass. They give you a mass as 0.5 kilogram, 0.5. Then your velocity, they said, is 4 meters per second. You say squared. Your radius is what? Is 1.5. Therefore, your final answer is going to be something like 0.5 multiplied by 4 all squared divided by 1.5. Your answer is going to be 5.33. 5.33 what newtons is a force. Ne? Another question says what? Calculate the tension at the top. Understand? You are going to draw a free body diagram at the top. You cannot calculate something without a free body diagram. This is the free body diagram at the top. Ne? So the tension is going where? The tension is going upward, downwards. Understand? The tension is going where? The tension is going downwards. Ne? This is the tension. Therefore, another one we have what? As long as the force has the what? Has a mass. The force has also what? The force of gravity. We have also what? We have Fg and what? And the tension. So I told you always all the time, when you are applying this formula, let's say letter B. B. When you are applying this formula of F net equals to the centripetal force, you must choose the forces that are going to the center of the circle. The forces that are going where? Are going to the center of what? Of the circle only. Ne? You must choose them to be positive. Ne? For this instance, these all two forces are going where? Are going to the center of the what? Of the circle, meaning they have to be positive, all of them. Ne? You are going to have what? You are going to have tension plus what? Plus force of gravity. Our centripetal force is what? Is mv squared divided by r. Understand? They want the tension. It means the tension is going to be what? Mv squared divided by r minus mg, which is the gravitational force. You can substitute this value here, since this thing and this thing are the same thing. Ne? If you want, or you can substitute the value of mass and velocity. Therefore, you are going to remain with what? With 5.33 minus your mass is what? Your mass is 0.5. The gravity is 9.8. Therefore, you press your calculator. You say answer minus 0.5 multiplied by 9.8. Your answer is going to be a 0.43. 0.43 is tension, is measured in what? In newtons. Don't forget. Ne? This is your tension of the string at the top only. Understand? They say calculate the weight of the stone. The weight of the stone, I told you the weight is what? This C, the weight equals to mass times gravitational force. Understand? So what is your mass? Your mass is 0.5. Your gravity is what? Is 9.81. Therefore, your answer is going to be what? 0.5 multiplied by 9.8. Your answer is going to be 4.9 what? Newtons. Understand? Another question says what? Calculate the net force acting on the stone at the what? At the top. They want the net force. It means they want what? Letter D. They want the F net. They want the F net. Understand? They want the F net. F net, they're talking about the forces that are at the top, which means we want to find this thing. You know, forces are vectors. They have direction. We're going to choose downwards as what? Is positive. Meaning I'm going to say what? Tension plus what? Plus Fg. Ne? Therefore, what is your tension? Your tension here is what? Is 0.43. What is your weight? Your weight is 4.9. 4.9. All these things are measured in what? In newtons, because they're what? They are a answer plus 0.43, because they are what? They are a what's this thing? They are the vectors. Therefore, your answer is going to be what? Is going to be 5.33 0.33 newtons. Understand? That's the net force. That's the net force. Understand? So let's check another question. Oh, they're all complete. Let's check another question. Number 3. They're talking about what? A 1.2 kilogram object spin in a what? Vertical circle. Key point vertical circle. Start by drawing your what? Your vertical circle before you start with everything. Understand? They say the radius of that circle is what? Is 2 meters. It completes 5 revolution. Revolution is the same as what? As cycles. Understand? In what? In 10 seconds. This thing is your what? Is your time. Not your period, is your time. Understand? Yes. So they say the radius of the circle is what? The radius of the circle is something like what? Is 2 meters. Understand? So they say that object took what? Make a 5 revolution in what? In 10 seconds. Meaning for it to round like this, 1, 2, 3, 4, 5. It took how many seconds? It took seconds. It's like it was like this. 1, 2, 3, 4, 5. Understand? So that thing took 10 seconds to do what? To complete full 5 cycles. Ne? The question says calculate what? Calculate the frequencies. Question A. They say calculate the frequency. They say letter A, calculate the frequency. I told you the frequency is the same as what? 1 over period, or is the same as what? Is the same as time divided by number of cycles. Understand? And I told you that the period is equals to what? Equals to the time divided by the number of cycles. Bear that in mind. Or what? Or 1 over frequency. Understand? So we are given what? We are given time, we are given number of cycles and what? And a time. They want the frequency. So we're going to substitute. What is our time? Our time is what? Is 10 seconds. What is number of cycles or revolution? Is 5. We're going to have 5. Therefore, our answer is going to be what? Is going to be 10 divided by 5 is the same as what? 2 what? 2, not 2 seconds, but then 2 hairs. 2 hairs or what? No. The formula is wrong. Sorry. The formula is wrong. I read the wrong formula. Frequency is what? Is number of cycles divided by the time. Ne? So what is the number of cycles? Number of cycles is the number of revolution. Ne? It took how many revolution? It took 5 revolution. With how much time? With 10 seconds. Understand? 10 seconds. So the answer is going to be what? 1 over 2, which is the same as 0.5. 1 over seconds is the SI unit for frequency, or you can say hertz. Understand? So letter B, they say calculate the period. The period, I told you, you can say is the inverse of what? Is the inverse of the frequency. Is the inverse of the frequency, or inverse of the formula of the frequency, which is T over number of cycles. Ne? So you can use this formula, or you can use this formula and substitute the value of what? Of F by itself. Or you can use this formula, substitute the value of T and number of cycles. Ne? So the easiest one is to use this formula to finish fast, meaning we are going to have what? 0.5. Therefore your answer is going to be what? You say 0.5, you press inverse there, then your answer is going to be 2 what? 2 seconds. Ne? Another question says calculate the linear speed. The linear speed, they are talking about what? They are talking about velocity. And then I told you the formula for velocity equals to what? Equals to 2 pi r divided by the period. Understand? So what is your what? What is your radius? They gave you the radius on the statement. They said is what? Is 2. You have showed it here is 2. You substitute your 2. Your period, you calculated it here, is also what? 2, meaning this one cancel that one. Your answer is going to be 2 pi, but then you must put it in decimal form, not in radians. Therefore your answer is going to be what? Is going to be 6.28 what? Meters per second. Ne? So letter D, they say what is the centripetal force at the bottom At the bottom is where? This is the bottom part. Ne? This is the bottom, which means you are going to have something like this. They say the speed is what? Always, all the time, the speed is perpendicular to the what? To the radius. Ne? The speed is what? The speed is 8 meters per second. Understand? They say calculate what? The centripetal force. I told you, always, all the time. Letter D, centripetal force. Centripetal force is the same as this. Centripetal force equals to mass times centripetal acceleration, and then centripetal acceleration equals to what? Velocity squared divided by the what? By the radius. Understand? Divided by the what? By the radius. And then we can take this thing and substitute it here, meaning the centripetal force equals to the mass times velocity squared divided by what? By the radius. What is the mass of that object? The mass of that object, we find it to be what? To be 1.2 kilogram. It's 1.2 kilogram. The velocity is what? The velocity at the bottom is what? Is 8 meters per second. Understand? Which is 8 squared divided by the radius, which is 2. I'm not sure. Yeah, the radius is 2. Therefore, your answer is going to be what? You're going to say 1.2 multiplied by 8 all squared divided by 2. Your answer is going to be what? Is going to be 38.4 meters per second. This is your final answer. Understand? This is how you calculate the centripetal force where? At the bottom. Understand? So let's check number 4. Then number 4, they are talking about a 0.5 kilogram ball is dropped from a height. It's dropped from a height of 10 meters before it enters a what? A vertical circle. Let's draw our vertical circle. You must draw the scenario first. You cannot just think of things that you don't see. Understand? A vertical circle. They said is dropped from the a 0.5 kilogram ball is dropped from a height of what? 10 meters before it enters what? It enters a vertical circle. Understand? So this question is kind of like tricky. It's very, 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 very tricky. Ne? It's very tricky. For example, here they are talking about something that is very tricky that you have to put in mind. Ne? They are talking about a 0.4 kilogram ball is dropped from the height. Ne? Before it enters what? Before it enters what? A vertical circle. Ne? So before it enters a vertical circle, the object can be here. Can be here, and that object was here. Understand? That object was here, and it was dropped from where? It was dropped from a height of what? Of 10 meters before it enters a vertical circle. So this thing already is inside the what? Is inside the vertical circle, meaning what? Your thing won't work. You must make this thing a half circle. Ne? They're trying to distract you. You must make this thing a what? A half circle, meaning we are going to have something like this. Something like this. Understand? Something like this. I want to make a beautiful circle for you to understand easily. This is your circle, ne? Let's say this is the what? This is the ball, ne? This is the ball, and they say the ball is dropped from a height of what? Of 10 meters. Let's say that ball is here, ne? Let me draw this scenario. The ball is here. This is the ball. It's dropped from a height of what? They are saying from where? From here. We are talking about the height till here. The height is what? Is 10 meters. Understand? So before it enters the circle, now it's entering the circle, ne? It's dropped from the height of 10 meters before it enters a vertical circle. Calculate the speed at the bottom before the circular motion what? Starts. Understand? The speed at the bottom. Understand? The speed at the bottom they are referring to here. Before the circular what? the circular motion start, because the circular motion is going to be something like this. That object can be dropped and come like this. You see, come back here and come back here. Understand? So they want the speed here. Understand? I know, I told you always, all the time, the speed here is always the same. The speed through in a circular path is always the same. Ne? Don't be distracted. And this height here, they're trying to fool you. This height is the radius of here. They're the same thing. Understand? They're the same thing. That height is the what? Is the radius. They're trying to trick you, but then they won't. It's the radius, which is 10 meters. Ne? So you have to draw the free body diagram here. So you must know now we are acting on a what? We are now acting on a surface. Ne? And you must know on a surface we have a what? We have a normal force. So draw a free body diagram before. You cannot do something without a free body diagram. That's highly impossible. Ne? So we have, as long as the force that has the object has a mass, it means has a what? Force of gravity. And we also have a what? We also have a what? A normal force. Understand? We also have a normal force. They want the speed at the bottom. Ne? I told you what? The speed is what and what. So let's try and see what do we have that can help us. Ne? So we know that what? F net equals to the what? Equals to the centripetal force. Understand? So the force that is going to the origin of the circle is the one that we are going to choose it to be what? We are going to choose that force to be to be positive. Every force that is going to the origin of the circle, you are choosing that force to be what? To be at the origin of the, that is going to the origin like this. You choose that thing to be what? You choose it to be something like what's this? You choose it to be positive. Understand? It must be positive. Meaning at this point, the force that acting to the origin here is what? Is the normal force. So it means I'm going to say normal force minus Fg equals to Fc, or I can say what? M v squared divided by what? By the radius. Since well they want the what? The speed, they want the velocity. Ne? So what is the normal force? What is the Fg? Understand? How can I calculate those two things? Ne? The first thing first, I must calculate the normal force. I must calculate the normal force, and then we know the normal force is what? The normal force equals to Fg. One thing you must bear in mind, the normal force equals to Fg. Understand? Those things are simple, man. Normal force equals to what? Equals to Fg. So it means we are going to have what? Let me see. We have the motion starts. We're going to have something like this. This thing is common sense, ne? Time taken to fall, the speed at the bottom just before the circulation start. Oh, just before the circulation start, they are trying to trick us, and they also tricked me. They told you that what? The ball is dropped, ne? They want the velocity where? They want the velocity here, just before what? Before it start to circulate. They told you this thing, it was what? It was dropped, meaning the velocity is what? It was 0 meters per second before. Understand? So if it was 0 meters per second, they want the what? The speed of the ball at the bottom just before it start to circulate. Ne? They want the speed here. Ne? And then you have a what? You have a height. You also have a what? Velocity. You want velocity final here. Ne? It means v final squared equals to v initial squared plus twice acceleration change in y. Understand? So we want v final. Our v initial is what? Is 0 plus twice. Our acceleration is what? Is negative. Let's choose the one that is positive. Positive 9.8. Our height is 10. So I'm going to have something like this. You're going to press your calculator. You're going to say square root your velocity final at the bottom before it start to circulate going up there. We're going to have what? 0 plus 2 into 9.8 multiplied by 10. The answer is going to be 14. 14 what? 14 meters per second. Understand? They say calculate the time taken to fall, the time from here to here. Understand? We are going to use, this is A, this is B. The time, we know velocity final equals to velocity initial plus acceleration changing time. Understand? Because free fall happened there. Understand? Free fall happened. That thing, it was moving under the influence of what? Of force of what? Force of gravity. Understand? So velocity final is 14, initial is 0 plus acceleration is what? Is 9.8 multiplied by t. I divide by 9.8. My time is going to be what? Answer divide by 9.8. My time is going to be 1.43. 1.43 what? Seconds. So let's try and see again. Potential energy lost. Understand? Potential energy lost. They want what? The potential energy, EP lost, ne? Equals to what? You know, the potential energy stored plus the potential energy lost plus what? Plus the potential energy in excess equals to the potential energy initial. Understand? These things are practical. The potential energy initial equals to the potential energy lost plus the potential energy what? Excess. You can say excess or stored. Excess. Understand? So what is the potential energy excess? Is the one that is remaining, ne? So initial potential energy initial is here, the one that is remaining is here. Understand? So let's check the potential energy initial is here. So our potential energy initial is going to be what? Here is going to be mgh initial. Here is going to be mgh lost, ne? Plus what? mgh what? Excess. Excess is where? Here at the what? At the bottom is the one that is remaining. Excess, ne? So this mass will cancel. Let's find the subject form, which means I'm going to have what? mgh initial minus mgh excess equals to E lost is what I want, ne? So this one is going to be 0 because of the height. Understand? So it means the potential energy lost is going to be something like m height initial. My mass is what? What is the mass there? The mass is 0.4. The mass is 0.4. The gravity is 9.8. Then the height is what? Let's try and check the height there. The height is 10. The height is 10 there. You're going to substitute your 10. Then you press your calculator. You're going to have 0.4 multiplied by 9.8 multiplied by 10. Understand? So your answer is going to be 39.2 joules, ne? It's going to be 39.2 joules, ne? Let's check another. They say kinetic energy at the bottom, kinetic energy here, ne? Which is D. EQ at the bottom equals to 1 over 2 mv squared. You must substitute what? I must substitute the velocity that I got at the bottom. In the velocity that I got at the bottom, it was what? It was 14 meters per second. I'm going to have what? I'm going to have 1 over 2. My mass is what? Is 0. Is it 0.4 or 0.5? Yeah, it's 0.4. It's 0.4 multiplied by 14 all squared. So I'm going to have what? I'm going to have 1 over 2 and then 0.4 14 all squared. Your answer is going to be 39 point what? 39 let me press again. 39.2. You're going to be 39.2. Understand? 39.2 and then 39.2 what? Joules. Understand? Simple as that. These things are simple, guys. Not that hard. Very, very simple. Here we got the 9.2 joules. Simple stuff. So let's go to another question. An object of mass 1 kilogram. Things are going to be simple there. 1 kilo. When I see one, I know as things are going to be simple for me. Ne? So whatever what in 1 kilogram swings in a vertical cycle. Key point. I'm throwing my vertical cycle now. Understand? I'm throwing my vertical cycle. A radius of what? 1.5 at the bottom. At the bottom is here. A radius start from here to here. The radius is 1.5. I don't know which force is acting. Ne? So they say the tension, or they are talking about the tension. They say the tension is measured in meters. Don't confuse the two. Then they say the tension is what? The tension is what? Is 40 newtons. You see, that's the tension. Check the SI unit. Calculate the speed at the bottom. Understand? The speed of the bottom. You cannot calculate the speed of the at the bottom without a free body diagram. Throw your free body diagram. Your tension is going where? Is going upward. Ne? Your tension is going upward at the bottom only. You have tension. If the object has a mass, it means you have a gravitational force. Ne? They want the speed. Ne? So what we have to do is to what? Is to know that what? That F net equals to what? Equals to centripetal force. Understand? So what is the forces that is acting? I told you choose the forces that are going to the origin. The forces that are going where? To the origin of what? Of the cycle. To be what? To be positive. Which one is going to the origin between the two? Is the tension. The Fg is going away, but the tension is going to the origin. You choose the tension to be positive, but then you also include the Fg, meaning I'm going to have what? Tension minus Fg equals to centripetal force, which is what? mv squared divided by what? By the radius. What is the value of my tension? My tension, they told me, is what? Is 40 newtons. So I'm going to have 40 minus mg. The mass is what? The mass is 1 kilogram. I told you when the mass is 1 kilogram, things are going to be simple. 9.8. Understand? Therefore, mass is 1. Things are going to be simple. V squared. The radius is 1.5. Understand? Meaning I can multiply both sides by what? By 1.5. Multiply by 1.5. This one cancel that one. Meaning I'm going to say what? Square root of that thing. Things are simple now. Due to the mass as 1. Velocity is what? You press your calculator there. You say square root 1.5 into 40 minus 9.8. I ignore the 1 because things are simple because there was a 1. You get your answer as 6.73 meters per second. You get 6.73 meters per second. You see? Simple stuff. Calculate the centripetal force. B. You don't waste time. Centripetal force equals to what? mv squared divided by what? By the radius. Understand? What according to me, since what the mass is 1, the centripetal force is equals to the centripetal acceleration. Do you know that? But then let's ignore that. The mass is 1. The velocity is what? Is 6.73 all squared divided by the radius, which is 1.5. Check. If they ask us to calculate the centripetal force, acceleration, you will see it will be equal to the centripetal force due to the mass is 1. We observe, ne? Must be a good observe. All squared divided by 1.5. Your answer is going to be 30.2 what? Newtons. Let's check. Oh, they say calculate the tension at the top. Sorry, but then this one is for practice. Ne? You will what? You will just emit or absorb knowledge. It comes from you. Ne? You learn something. They say calculate what? The tension at the top. That is why I assume that thing will be the same. The tension at the top they are referring here. They want the tension here. And at the top, the tension is going downwards. Ne? Oh, we calculate the centripetal force. Now they want the what? They want the weight. Sorry, I'm misleaded. They want the weight, which means you are going to say is ABC d. The weight always all the time equals to mg. The weight is close to 9.8 newtons because the mass is 1. Understand? Simple stuff. Calculate the tension of the force at the top, ne, is here. Understand? And then they say the velocity there is what? The velocity is what? The velocity is 6 meters per second. Simple stuff. So I'm going to look for the tension now. Ne? I'm going to throw a free body diagram. Let me throw my free body diagram there. My free body diagram at the top is this one. This is my free body diagram. Oh, sorry. At the top, the tension is going where? Let me throw it here. The tension is going downwards, and then the FG is also accompanying it. It means I told you the force that are going to origin, take them as positive. Understand? Meaning I'm going to have what? Is A, B, C, D, E. Is D actually. That one of weight, it was C. So F net equals to the centripetal force. You see? So we just sum them because they are moving in the same direction. Mg equals to mv squared divided by what? By the radius. The tension equals to be what? Equals to be mv squared divided by what? By the radius, and then a minus what? Minus mg. Let's do the little bit of mathematics and save time. Let's remove the common factor of mass. I'm going to have v squared divided by r minus gravity. And if you can check, we calculated this centripetal force there at the top here, and we got it as what? As 30.2. Means we're like the mass is 1. That is why I removed the common factor to waste my time. The velocity is what? They gave me the velocity, they say 6 squared. I'm going to have 6 squared divided by the radius, which is 1.5 minus 9.8. You press your calculator, you will be done. So you are going to have what? You are going to have 6 squared divided by 1.5 minus 9.8. Your answer is going to be 14.2. 14.2 what? Newtons is the new force. That is why those forces are not the same. If you can check the force here at the bottom, is strong than the force at the top, ne? So let's go to number 6. Yeah, we're finishing now. Only 10 problems. We are having what? We are having a 0.3 object travels in a vertical circle. Key point: vertical circle. Understand? So in that vertical circle, that circle has a radius of what? Of 0.5. The radius is 0.6 meters. It completes 3 revolutions. 3 revolutions is the same as 3 cycles. In what? In 6 seconds, this thing is the time. Understand? Determine the period. A. The period. Simple stuff. Period equals to what? Time divided by number of cycles. What is the time? 6 seconds. What is the number of cycles? 3. Your answer is going to be what? Is going to be 2 seconds. Then B. Calculate the frequency. Frequency you can say is 1 over t. Then you finish very fast. You say 1 over 2, which is what? 0.5 what? Hertz, or 1 over seconds. If you are smart, go and write 1 over seconds. Ne? So, or you can say frequency equals to what? Equals to number of cycles divided by the time. You're going to have what? You're going to have number of cycles was what? It was 3. 3 divided by 6, which is the same as what? 0.5. 1 over seconds. Or you can say hertz from high school, but then I prefer 1 over seconds to show them you know what we are doing. So they say calculate the linear speed. See, calculate the linear speed. They're talking about the velocity. Velocity equals to what? 2 pi r divided by what? By the period. Ne? So we are going to substitute what? 2 pi. Your radius is what? They give the radius as 0.6. 0.6. Then the period, you calculated it here. Don't mix. Ne? So your period was what? Was 2. Therefore your answer is going to be what? Is going to be, you say shift pi multiplied by what? 0.6. Your answer is going to be 1.88. 1.88 what meters per second. This thing is your final answer. They say calculate the centripetal acceleration. Letter D. Centripetal acceleration equals to what? Velocity squared divided by the radius. Always, all the time. That one does not change. What is your velocity? 1.88 all squared. Divide your radius is what? My radius was 0.6. Therefore, my final answer is going to be what? It's going to be 1.88 all squared divided by 0.6. Therefore, my answer is going to be 5.89. 5.89 what? Meters per second squared. Don't forget the SI unit of what? The SI unit of this thing, what? What's this? The SI unit of, what's this thing, man? SI unit, yeah, acceleration, ne? Don't forget to. So another village number 6. Let's go on number 7. Number 7, they are talking about a 0.75. This thing of 0.75 kilogram, it reminds me a question that I once wrote in my grade 12 with electrostatics. I loved that chapter. But my favorite chapter, I did not have a favorite chapter. Maths and science was always, all the time, my favorite chapter. I mean, my favorite subjects. There was no subject that will be higher than physics, mostly actual, in my report. So they say a 0.5 kilogram stone withheld a vertical cycle of a radius of what? 0.9 meters. Ne? A vertical cycle, key point, vertical cycle. You draw your vertical cycle there, vertical cycle. So with that vertical cycle, what they say, the vertical cycle has a what? Has the radius of what? Has a radius of 0.9 meters. At the top, the tension of the string is 1.5. Yeah, I love this question. At the top, ne? At the top, they are meaning here. The string is what? The tension of the string is what? Remember, the tension is not the same at the top and the bottom. The tension is what? Is 1.5 newtons. This question looks similar, ne? 1.5 and 0.75. This question reminds me of something. And then they say in the string, they say you must know that the radius of the tension also is also 0.9. The length actual. Find the speed at the top, ne? You say find the speed of at the top. You say what? You say A. You know you want to find the speed, ne? You know you're going to say F net equals to centripetal force. You draw a Freiburg diagram at the top. You cannot calculate without that thing, ne? You're going to have a tension going downwards, and then you're going to have what? Fg also accompanying the tension. Meaning, as long as I told you always, all the time, you pick the force that is going to the origin to be what? Positive. They are all going to the origin. It means they are going to be what? Positive. I'm going to have what? Tension plus what? Mg equals to mv squared divided by the radius. They want the what? They want the velocity. Okay? So I'm going to multiply both sides by 1 over r. 1 over r. Or you can substitute, you can substitute by r actual. Multiply both sides by r. By radius. Multiply both sides by radius. Therefore, I know this one will cancel this one. I'm going to remain with what? Mv squared equals to the radius tension plus mg. Therefore, you divide both sides by mass. By mass, this one cancel that one. It means velocity goes to be what? Square root of the radius into tension plus mg divided by the mass. Therefore, you start to substitute your things, or you can substitute straight here. Therefore, I'm going to have square root radius. What is the radius? The radius they gave me as 0.9 into the tension they gave it to me 1.5 newtons. 1.5 plus the mass is 0.75. Gravity is 9.8. Close the brackets. The mass is how much? Is 0.75. 0.75. you press your calculator, will be done. Say square root of 0.9 into 1.5 plus 0.75 multiplied by what? Multiply by 9.8 divided by 0.75. Let me see, I left the brackets here. Answer is going to be 3.25. Answer is going to be 3.25. I'm going to write 3.25 what? Meters per second. So we're going to have a 3.26 actually. 3.26 meters per second. Understand? So another question says calculate the centripetal force. Simple stuff. Say B, centripetal force equals to what? mv squared divided by the what? By the radius. What is the mass? The mass is 0.75. What is the velocity? 3.26. We calculated it here, all squared. The radius is how much? The radius is 0.9. You press your calculator, you will be done. Therefore, you are going to have what? 0.25, 0.75 multiplied by 3.26 all squared divided by 0.9. Therefore, your answer is going to be what? 8.86 meters per second. And they say B, this C, acceleration at the top is still the same thing, Anger, as the velocity at the top. You know the velocity at the top is the same, ne? So you see, centripetal acceleration equals to what? Equals to v squared divided by what? Divided by the radius. Or you can say FC, centripetal force, equals to what? Mass times what? Centripetal acceleration. Therefore, centripetal acceleration is going to be what? Is going to be centripetal force divided by the mass. You'll choose, ne? So centripetal acceleration this side is going to be the velocity, which is 8.86 all squared divided by the radius of 0.9. This side is going to be, I substituted the wrong things. This SI unit is wrong. The SI unit of here is newtons. That is why I chose this thing, which is wrong. So I'm going to have a velocity squared. What is my velocity at the top? The velocity at the top, I calculated it somewhere, which is what? 3.26. Which is 3.26 all squared divided by a radius of 0.9. This side, you can take 8.86 divided by mass, which is 0.75. The answer will be the same. You're going to have what? You're going to have answer divided by 0.75. Answer this side is going to be 11.81 meters per second squared. This side you are going to have what? 3.26 all squared divided by 0.9. The answer is going to be what? 11.81 meters per second squared. Simple maths and science. Let's calculate the potential energy at the top relative to the bottom. You see, relative to the bottom, which means from here to here, relative to here, which means you're going to take this what? The radius and this one from here, you multiply them by what? By 2. You find the what? The potential energy. It's letter what? Letter D. Letter D. Potential energy equals to mass gravity times height. Your mass is what? Is 0.75. Gravity is 9.8. Height relative to the bottom from here to here. Understand? So I'm going to have 0.9 multiplied by 2. 0.9 multiplied by 2. So my answer is going to be what? 0.75, 9.8, 0.9 multiplied by 2. Answer is going to be 13.23 joules. Let's move. Number 8, we are done. No. A 1.5 kilogram object spun in a vertical circle. A 1.5 kilogram span in a what? Vertical circle. Key point. We are gone. With a radius of 2 meters. 2 meters. It moves the constant speed of what? Of 5 meters per second. Obvious. The speed is always constant here. Understand? They say that thing is moving what? Let's assume it's here. It's moving with the speed of what? Of 5 meters per second. And the mass of that thing, they say, is what? The mass is 1.5 kilogram. Calculate the centripetal force. Centripetal force equals to what? Mass velocity squared divided by the radius. What is our mass? Our mass is 1.5. Our velocity is 5 all squared. Our radius is 2. So I'm going to have what? 25 divided by 2 multiplied by 1.5. 1.5 multiplied by 5 squared divided by 2, which is 18.75. 18.75 what? Newtons. That question says calculate the tension at the top. At the top is here. We're talking about the tension. Yeah? It's letter B. So we are going to draw a free body diagram at the top. You cannot calculate that thing without drawing its free body diagram. If it has a mass, it has a force of gravity, and it has a what? It has a tension going down. I told you, whenever you are applying the formula of what? Centripetal force, this formula F net equals to the centripetal force. You must make sure you choose the force that is going to the origin to be what? To be positive. Ne? So all the forces are going to the origin, meaning that they have to be all positive. I'm going to have tension plus mg. Centripetal force, I calculated it here. No time wastage. 18.75. The tension is what I want. I'm going to have 18.75 minus mg. My mass is what? My mass is 1.5. 1.5, 9.8. I'm going to have what? Answer minus into 1.5 multiplied by 9.8. The answer is going to be 4.05. 4.05 newtons. Following question, time for one full cycle. One. How many cycles? Number of cycles. How many? 1. Time is what they want. Yeah. So what is the formula that has a time and a period? Ne? You know what velocity equals to 2 pi r. Please keep this formula in memory. It's easy to forget that formula. Ne? So we want the what? The period, which means velocity multiplied by t equals to 2 pi r. I divide by velocity. Divide by the velocity there. Then this is my period. Let me calculate the period. Period equals to be 2 pi. My radius is what? Is 2. Is 2. The velocity is what? What is the velocity? Did they give it? Yeah, 5. Is 5. So the answer is going to be what? 4 multiplied by pi divided by 5, which is going to be 2.51. 2.51 seconds is period, ne? And we know the period equals to what? The time taken to complete those number of cycles multiplied by number of cycles. The period is what? Let me make time subject of the formula. Period multiplied by number of cycles. The period is what was 2.51. Number of cycles is 1. It's going to be 2.51. The time taken to complete how many cycles? 1 cycle. Understand? Simple stuff. Nothing more, nothing less. Let's check number 9. A roller coaster. A roller coaster of mass 500. Ne? Over the top of a circular hill. Let's draw a hill, circular hill. This is our hill. draw it like nicely, or let me draw it here. This is our circular heel. You cannot have a heel like this. Ne? Use common sense. This is the heel. Understand? It's a half circle. It means this thing is the origin of this circle, of this half circle here. Let's make your life simple here. This thing is a circle. They're trying to trick you, and this thing is also a circle with the origin here. Don't be fooled. Understand? So they say a heel of a radius 10. It means the height. They can say a height, ne? They can say a height to trick you. At 12 meters per second, a roller coaster of 500 kg passes over a top of circular heel. This is the heel. They say that roller coaster passes here with a speed of what? Is going that direction. The speed of what? Of 12 meters per second. And they say the mass of that thing is what? The mass of that roller coaster is 500 kilograms. 500 kilograms. You see? And the question says what? The question says calculate the centripetal force at the top. To calculate the centripetal force, the formula does not change, ne? Centripetal force equals to mv squared divided by the radius. What is the mass? 500. Velocity 12 all squared. Radius 10. This thing can cancel that one there. We remain with 50, which means I'm going to say 50 multiplied by 12 all squared. I'm going to have 7,200. Understand? Yes. So normal force at the top, B. They're talking about the top, most. Yeah. Normal force at the top. At the top, remember, this thing is a heel again. This thing is a heel. Obviously, is a surface. It has a normal force, ne? So I don't know why did they tell you that, man. They were supposed to calculate the centripetal force without giving you the velocity. So we're going to have normal force acting that direction. We're going to have a normal force, and what? Force of gravity going that direction, ne? Always, all the time, when you apply this formula of F net equals to centripetal force, choose the force that is going to the origin of the circle, the force that is going there, the force that is going to the origin of the circle, ne? To be what? To be positive. For now, this one is not going to the origin, it's going away from the origin, because the normal force is acting that direction, and then Fg is acting that direction. You see? So meaning we are forced to take what? The Fg, since what is going to the origin of that heel. We're taking it to be what? To be positive. Ne? We're going to have Fg minus normal force equals to centripetal force, which is what? We've calculated it here, is 7,200. Then the Fg is not what we want. I can take that 200 that side. I'm going to have mg minus 7,200 equals to my normal force, ne? Then what is mg? Mg is my mass, which is 500 multiplied by gravity minus 7,200 equals to the normal force. So I'm going to have 500 multiplied by 9.8 minus answer. No, does not make sense. It's not making sense at all. Let me see something. Let me see. Fg is going positive. Normal force is going to the right. I'm taking that thing that side. This one that side. I'm having a mass of what? Let me see. I'm having a mass of what? Of 500 multiplied by 9.8 minus 7,200. Oh, it's making sense. It means the force is what? Is opposing the motion that we chose. Again, we chose a downwards as positive. It means your is opposing. It's going to be negative 2,300 newtons. Understand? It's opposing. So we are going to tell them that the normal force equals to what? 2,300 newtons, where upward is a vector, upward since well is opposing. Understand? It's like friction. So they say, what is the speed will make the normal force 0? Or what is the roller coaster at risk of losing contact? Okay, what is the roller coaster? Is the roller coaster is the roller coaster at risk of losing contact? Ne? Where? Let's say the roller coaster is here. Is it at risk? Will it move this direction and go that fall? Or will it be moving this direction and then falls like this? Is it at risk? For that thing to be at risk, let's try to calculate what? Let's calculate what the minimum velocity that is needed. Ne? The minimum velocity for that thing to do what? To not to fall. Understand? To not to fall. So let's try to calculate the minimum what? Velocity for that thing to not to fall. So let's do it. It's number what? We want to compare this velocity and the minimum velocity needed. Understand? Is what we want to calculate. Ne? So we're going to say C and calculate the force, the what? Calculate the what's this? Calculate the minimum what? The minimum, what's this thing called? The minimum velocity. But then you can just answer them. You can say, no, it's not at risk. Understand? It's not at risk. Since well, it was able to go at the top of the cliff, it means it can also be able to go down at the bottom of the cliff. Understand? It's practical. But what is the speed will make the normal force 0? What will make the normal force 0? It means you will assume this thing is 0 and check what is the speed. We're going to say what? F net equals to what? FC. So I know what they're talking where. We will make normal force 0 where. This question is not specific. They should talk what they are talking about here or here. But then let's take the top. Ne? So at the top, when you are doing a free body diagram, we have normal force minus, we have Fg minus normal force. We have Fg minus normal force. This thing is the same as mv squared divided by what? By the radius. They are saying this thing is what? Is 0. Meaning I'm going to have mg equals to mv squared divided by the radius. These masses will cancel each other. Meaning v equals to square root of gravity multiplied by the radius. Is the what? Is the speed that the thing will have. Ne? Is the minimum speed. Ne? So our gravity is 9.8. Radius is what? Radius is 10. We're going to take square root of that. Square root of 9.8 multiplied by 10 is going to be what? 9.89. 9.89 what? Meters per second. Yes, that's your answer. So let's check another question. A pendulum of a length 1.2 swings in a vertical circle. Ne? This is a pendulum. Or should I do it like this? Should I say like this? A pendulum is a swing. Ne? That swing does like this. You push someone, it does like this. It's a pendulum. Ne? That's how a pendulum works. They say a pendulum swings of a length 1.2. Its length is 1.2. A vertical circle at this lowest point here. Its speed is what? Is 4 meters per second. Find the centripetal force. You know centripetal force is simple, guys. mv squared divided by what? By the radius. What is the mass? The mass of the thing is what? they did not give us the mass. Why? The tension of the string, this, you see guys, they made a mistake. They have to give us a mass. Yes, they have to provide us with a mass. Let's suppose the mass is let's say 2 kilogram. The pendulum is like heavier, let's say maybe 10 kilogram. Then our mass is going to be 10, velocity is 4 all squared, our radius is 1.2. Our answer is going to be what? 10 multiplied by 4 squared divided by 1.2, which is 133.33 newtons. The tension of the string at the what? At the lowest point, B. The pencil is also tired. So they what? They want the tension of the string at this point here. Understand? We're going to draw a free body diagram there. The tension is going upward, Fg is going downward. Ne? So it means I'm going to have what? F net equals to centripetal force. So I'm going to take the forces that are going to the origin, which is this one. I'm taking them as positive. I'm going to say tension minus Fg equals to mv squared divided by the radius. What is the tension? They want the tension. So therefore tension equals to what? Mass. What is my mass? My mass is 10, velocity is 4 squared divided by radius of 1.2, and then plus what? 10, 9.8. Meaning I'm going to say what? I'm going to say answer plus 10 multiplied by what? 9.8. The answer is going to be 231.3 what? Newtons. They say, what is the weight of the pendulum bob? You see, those people are mad. Sorry for mentioning that word. These people are saying something that is not accurate. How can you want a weight when you did not give us the mass? The mass is 10, 9.8. You have 10 multiplied by 9.8, which is 98 newtons. Calculate the period of the pendulum. They want the period, but then they did not give you number of cycles and whatsoever. Understand? I hope you can see the error. So in the next section, I'll be doing a horizontal what? Centripetal circular motion. Good night. 4 o'clock.